Okay, this is section 1.4C. We're skipping B. So this is kind of an introduction to solving by graphing. We're going to learn a couple different ways to solve a system of equations or a system of simultaneous linear equations, and this is the first one. So with this method, you're going to graph both of the equations on the same coordinate plane, and then the solution is going to be where the two intersect, just like we did with the apples and peaches. So let's look at this first one. 2x plus y equals 4, and y equals 4x minus 2. So what problems are you going to run into? This is number one, when you graph these two equations. Well, one of them is not in the slope-intercept form. And it's number two asks, what form of the linear equations do we typically use when graphing? Well, we know that that's slope-intercept form. So we've practiced this a bit, so you can rearrange them and put them in slope-intercept form. So it gives you the example of this one. We're going to rearrange that one, and it goes step by step on how to do that. This is probably something that would be good to highlight in your notes. So the first thing we're going to do in this step is we're going to subtract 2x from both sides to isolate y. So remember that 4 and negative 2x are not like terms, so you can't combine them. We know that. So now we have y equals 4 minus 2x, and then we're going to just flip those around and put the negative 2x in front so that it's in slope-intercept form, or this form. All right, so now we have y equals negative 2x plus 4, and you're ready to graph. Okay, so let's look at an example that's a little more challenging. So we're going to write the steps in as you go. You have 4x minus 8y equals 16. So the first thing we're going to do is subtract that 4x from both sides. So write that down. Subtract 4x from both sides. That's its sides. So now we have negative 8y. So now we're going to divide each side by negative 8. Okay? When you do that, you have y equals negative 2 plus 1/2 x. So you're just going to rearrange. Keep the sign straight so that the mx is the first on the right. Mx is the first term on the right. I just put it there first. So I really don't need to do this step, and I think I've taught you that. So you may not have to take that step, but it's there to remind you. Okay, we're going to do a couple together, and then I'm going to leave you on your own. We're going to do 3 together, and then I'm going to leave you to do the last 3 on your own, and I'll post the answers. So A, we're just going to shift that negative 5x, or that 5x over to the other side by subtracting it. So I have y equals negative 5x plus 9. So B, the first step we're going to do is move that 4x over to the other side. So I have 2y over here, and see, I automatically just put that there on the left side, but you don't have to. So now I'm going to divide everything by 2. Y equals negative 2x minus 6. That's B. Okay? It kind of goes up and down. These are numbered weird. Now here's C. Even though that x is in the middle, that kind of throws you off. It's negative, so I'm going to do the opposite, and I'm going to add it. So I have 4y, and I'm already going to put that over plus 16. This throws some of you. There's a 1 in front of that. So when we go back and divide by 4, my answer is y equals 1/4 x plus 4. Now I want you to do D, E, and F on your own, and I'll post the answer. So stop the video and do them on your own, please. Okay, the answer to D is y equals 2x plus 12. E, all you have to do is divide by -1. I have y equals negative x plus 2. It just changes the signs. F is y equals 2/5 x plus 3/5. Don't be afraid of those fractiony answers. They're still correct. All right, let's start graphing. Number 5, consider the linear equations 2x plus y equals 4 and y equals 4x minus 2 that were on the page before. So what we're going to do is we're going to graph them. When we flipped around 2x plus y equals 4, we already did this. We turned it into y equals negative 2x plus 4. So we're going to graph that. We're going to start at 4, negative 2, it's really important to use rulers here so that you can see where the actual intersection of the two lines is. Now I'm going to graph y equals 4x minus 2, so I'm going to start at minus 2, and my slope is 4/1. So now you can see the point they intersect. So we're going to find the coordinates of that intersection. So go over 1 up 2, and that's your point. So what B says, to verify the point of intersection that you found satisfies both equations. And that means just plug it in. So I'm going to plug in 1 for x, 2 for y, and see if they're equal. Oops. So 2 plus 2 is 4. So now I'm going to plug it into this one. I'm going to plug in 2 for y, 1 for x. So 2 is equal to 4 minus 2. 2 is equal to 2. So it works. So we found the correct one. That's just a way to check yourself. You should know if you're right. All right. So in the box, it says the definition of a solution to a pair of simultaneous linear equations is all pairs, if any, sometimes you have no solution, of numbers x, y that are solutions to both equations. This is the xy value that satisfies both equations. When solved graphically, it's the solution is the point where they intersect, if there is one. Sometimes we're going to see that there are not. So number 6 says, determine whether 3, 8 is a solution to the following system of linear equations. So we're going to plug the 3 and the 8 into both the equations. So I'm going to plug in 3 for x, 8 for y, and see if this is an equal. See if both sides are equal. So 6 plus 8 is 14. So this one works. Next equation, I'm going to plug in 3 for x, 8 for y. So 11 is equal to 11. So this one works. So both of them work. Number 7, let's check that. It says determine whether 0, negative 5 is a solution to the following system. So we're going to plug in negative 5 is equal to 2 times 0. We're plugging in 0 for x minus 5. So the first one works. Let's try the second. 4 times 0 plus 5 times negative 5 equals 25. So we have negative 25 equals positive 25. So that one doesn't work. So that is not a solution to that system. Not a solution. Okay? All right. We are moving right along. Let's go to number 8. Consider the equations y equals negative 2x and y equals negative 1/2 x minus 3. So we have to make sure they're both written in slope-intercept form, and then we're going to graph them on the coordinate plane, and we're going to check the point to see if it makes equations true. So we're going to graph this one first. Start at the origin. My slope is negative 2 down to right 1. So this one is y equals negative 2x. Now we're going to graph this one. We're going to start at negative 3, down 1 over 2. Down 1 over 2. Keep going like that. Now up 1 over 2. We want the whole thing. Okay, so let's be careful when we draw our lines. I can't use a ruler in here, but it's really important that you do. So here's where I intersect. That is 2. That is the point 2, negative 4. Now let's plug that into the equations to see if we did it right. So I'm going to plug in negative 4 for y and 2 for x. So negative 4 is equal to negative 4. Okay, first one's good. Let's check the second one. So negative 4 for y and negative 1/2 times, what was the other one, positive 2? Minus 3. So I have negative 4 minus 1 minus 3. So negative 4 is equal to negative 4. That one works too. So we found the right answer. It's a good way to check yourself. Number 9. Consider the equations negative 2x plus y equals negative 1 and y equals 2x plus 4. Make sure they're both in slope-intercept form and then graph them. So this one is obviously not in slope-intercept form. So let's get y alone by adding 2x to each side. So I have y equals 2x minus 1. Let's graph that one. My slope is up 2, right 1, 2 over 1. Down to left 1. All right, then this one already in slope-intercept form for us. So I'm going to start at positive 4. My slope is positive 2 again. Same as the other one. That's weird. And what's even weirder is they're not going to touch because they have the same slope. We already talked about, slopes of parallel lines in the last section. So we're not going to get an intersection. It's never going to happen. The lines don't intersect. So this is no solution. There is no point that would satisfy both of those equations. All right, I'm going to stop this here and then I'm going to start a second video.